So omega of 0 will be equal to cardinality of S. So cardinality of S is equal to 48. Now omega of 1 is omega of P1 plus omega of P2 plus omega of P3. So omega of P1 is a number of elements which are divisible by 2. The numbers which are divisible by 2. So that will be the integer function of 48 by 2, and omega of P2 will be those divisible by 3 at the integer function of 48 by 3 varum. Then this will be 48 by 5. So that will be 24 plus, so you will get 16 and 48 by 5. So the integer function will be 9. Okay, so that will be equal to 49, and let us find omega of 2. Omega of 2 will be omega of P1 P2 plus omega of P1 P3 plus omega of P2 P3. So this is the numbers which are divisible by P2 and 3. അപ്പോൾ 6 വരും പ്ലസ് ഇൻഡിജർ ഫംഗ്ഷൻ ഓഫ് 48 by 1 and 3 എന്ന് പറയുമ്പോൾ 10 വരും, 2ഉം 5ഉം. ഓക്കെ, then omega of integer function of 48 by then 3 and 5, so that will be 15. So this will be 8 and this will be 4 and this will be equal to 3. So you will get 15, and then omega of 3 is omega of P1 P2 P3. So that is 48 by 30 varum, so which is equal to 1. So therefore the required value E of 0 will be so you will get 48 minus 49 plus 15 minus 1. Okay, so that will be equal to 15 minus 2 varum, so which is equal to 13. So therefore the required number of primes is, so that will be equal to E of 0 plus 3 minus 1, so that will be equal to 13 plus 3 minus 1, which is equal to 15. So this is the value we have obtained using the sieve of Erasmus. So the problem we have done using the sieve of Erasmus can be also solved by using the generalized principle of inclusion and exclusion. So this is how we use the principle of inclusion and exclusion in this context.